Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve rational equations. And basically, again, if you've looked at my first two videos, when solving rational equations, the main important thing is we want to get the variable off the denominator. So to do that, we need to multiply by the LCD. So in this first example here, you can see that I have x plus 1 over x minus 4. Well, I can always rewrite x as x over 1. Therefore, you can see the denominator here, and you could write 0 as 1 over 1 as well. But you can see here in the denominator, my LCD in this problem is just going to be x minus 4. So what I'm going to do is I'm going to multiply every single term in my equation by x minus 4. And the reason why I'm doing that is that's going to now eliminate my denominator. So the reason why that does that is because using the division property. Whenever I have x minus 4 divided by x minus 4, those are going to divide out to 1. So therefore, I'm just going to be left with x times x minus 4 plus 1 equals 0. Well, if I apply distributive property here, I'm now left with x squared minus 4x plus 1 equals 0. Now, in my previous videos, we went ahead and started factoring. But the problem here is we cannot factor what two numbers multiply to give you 1, add to give you 4. That is a non-factorable problem. However, we still need to determine, do they have real? Is it no solution like the other one, where we are taking the square root of a negative number? Or are there solutions to it, but they're just not rational solutions? So to determine that, I'm going to use the quadratic formula. Before I use the quadratic formula, remember x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now remember, a in this case is 1, which is your coefficient of x squared. B in this case is negative 4, coefficient of your linear term. And c in this case is going to be 1. So now I'm just going to plug in those values. So I have opposite of b, opposite of negative 4 is positive 4, plus or minus the square root of negative 4 squared minus 4 times a times c, all divided by 2 times 1. Now, first thing I'm going to do is make sure I simplify my discriminant, because remember, if my discriminant is negative, then I know there's going to be no solution. So I have 16 minus 4, which is going to be 12. So actually, I am going to have some solutions. They're just not going to be rational. I can simplify the square root of 12. I can break up the square root of 12 as the square root of 4 times 2, which is 2 square root of 2. So therefore, that becomes x equals 2 plus or minus 2 square root of 2. No, that's 4 times 3, right? My bad. Divided by 2. That 2 divides into both of those. So my final answer is x equals 1 plus or minus the square root of 3. Now, obviously, if I plug that in through there, minus 4 is not going to get that to be 0. So therefore, I can say that those are going to be my two solutions. In this case, you can see that we have a binomial, and a trinomial. Now, again, my main focus has always been simplify, simplify, simplify. So the main important thing here is I'm going to want to see what is the simplified version of this quadratic. Well, if I was going to factor this out, what two numbers multiply to give you positive 3, add to give you negative 4, I can write that as negative 3 and negative 1. Perfect. So guess what? Now you can see that what is going to be my LCD of this problem? The LCD of this problem is simply just going to be x minus 3 times x plus minus 1. So therefore, again, what I'm going to do, like I did in the other problem, is I'm going to multiply each and every term by x3 minus 1 times x plus 1. OK, so now by using the division property, my x plus 1s divide to 1, my x minus 3s divide to 1, my x minus 3s and my x minus 1s divide to 1, leaving me now with an equation with no variables in my denominator. I basically have 2x times x minus 3 plus 1 times x minus 1, and then is equal to the number 2. So I can simply just apply distributive property here. It's a positive x, right? X minus 1. Yep. So I have 2x squared minus 6x plus x minus 1 equals 2. Well, I can simply subtract the x here and subtract the 2. Oops, whoa, what am I doing? These are on the same side, so you can just combine them. But here, I have to subtract my 2, because now, again, I have a quadratic that I want to solve. Since they're on the same side, I just combine those, but I want to set it equal to 0. So I have 2x squared minus 5x minus 3 equals 0. All right. So before I get to quadratic formula, I want to see, is this factorable? So I know that my first two terms of my binomials have to be 2x and x. And they have to multiply to give me -3, but then they add to give me +5. Well, thinking about the factors of 3, my factors of 3 are basically just 3 and 1. So I either do a 3 here or a 1 here, or I do a 3 here and I do a 1 there. Now I know that one of the factors, though, has to be negative, and I believe when I do my work, when I do the mental calculations in my head, this works. 2x times x is 2x squared. 1 times -3 is -3. 1x plus -6x gives you -5x. Perfect. So now I just go ahead and, that's still set equal to 0, set these both equal to 0, and then solve. So therefore, I have x equals -1/2 and x equals 3. Well, the problem is when I plug 3 back in there, 3 makes this 0. It also makes this denominator 0. Remember, you cannot have a value that makes it your denominator equal to 0. So therefore, this value is extraneous. OK? All right, into our last example. I just wanted to add at least one more of these. And in this case, you can see that I can simplify this by factoring out at x. So I'm left with an x plus 2. All right. So then again, you can see that my LCD for all of these is going to be the same, which is going to be x times x plus 2. So therefore, I'm going to multiply everything times x minus 2. Now, I did kind of run out of some space here, so I'm going to do a little bit of some mental calculation. And when I do that, when I multiply x times x plus 2 times my first term, my x's are going to divide out, and I'm going to be left with x plus 2 times x minus 3. When I multiply my LCD times this, the x plus 2's divide out, so I'm going to be left with a 3 times x. And when I multiply my LCD times my term over here, both my x and my x plus 2's are going to divide out, leaving me with a -6. So again, I need to go ahead and apply distributive property, or my FOIL. I'm going to finish that off, though, in my head. So I get x squared, that's 2x, -3x. So that's going to be -x plus 3x equals -6. I'm going to want to combine my middle terms since they're on the same side. Since this is on the other side, I have to add the 6 to both sides. So I have x squared plus 2x plus 6 equals 0. I don't remember that being the answer. Oh, I messed up somewhere. Oh, that should be a -6. Why did I multiply those out? No wonder you don't do things in your head, right? I didn't multiply that out correctly. Let's take that slower real quick. X times x is x squared. X times -3 is a -3x. 2 times x is a positive 2x. 2 times -6, or 2 times -3 is a -6. Plus 3x equals -6. So rather than doing it in my head, you can see I made a mistake. So that's why I slowed it down. So now I can combine all of these terms, since they're all variables, and I get x squared, -3x plus 3x. Those actually go to 0, so I'm left with a positive 2x. And then -6 equals -6. Well, when I add a 6 here to both sides, those go to 0. So I'm left with an x squared plus 2x equals 0. Now, to solve this, I can factor out the x, and I'm left with an x plus 2 equals 0. Apply zero product property. I get x plus 2 equals 0 and x equals 2. Therefore, my 0 is x equals -2 and x equals 0. However, if I plug in 0 or -2 into these places, then both of them are going to be extraneous. So they're both extraneous, or I could write no solution. So there you go, ladies and gentlemen. That is an example of how you solve rational equations. Thanks.